let's continue with similarity. Okay, now we're going to deal with property of angle bisector of a triangle. Okay, in this let's solve the theorem. Okay, first for property of angle bisector, and as we go further you will understand what all we are going to be doing. Okay, so let me read the statement. The bisector of an angle of a triangle divides the side opposite to the angle in the ratio of the remaining of the remaining sides. Okay, so let's see, the bisector is this CE. So the bisector of the angle of a triangle divides the opposite side. So this is the opposite side. It divides the opposite sides. Divides the opposite sides to the angle in the ratio of the remaining sides. So this upon this. So we have to prove as they have given. See now, in given triangle ABC, bisector of angle C intersects segment AB in point E. So this is the angle bisector intersecting at E. What we have to prove is AE upon EB is equal to CA upon CB. This we have to prove. Okay. Now for this we will use the property of corresponding angles, the properties of alternate angles, okay, and so on and so forth. Okay. Now some part is the construction, but I have already drawn it over here. Draw a line parallel to ray CE. So this is the line that is parallel to CE that is being drawn. Okay. So just remember that. Draw a line parallel to CE, that is BD. Okay. Passing through the point B. Extend AC so that it intersects D. So extend AC so that it intersects D. So this entire part is the construction. This is parallel to this. Okay. Now I want AE upon EB is equals to AC upon CB. So how will I do that? Okay. So always kids start with whatever is given. Now it is clearly given that ray CE is the bisector of angle C. Okay. Ray CE is the bisector of angle C. So first we will use that only. Okay. So proof. Now the given and all is written for you, so I will not write that. Okay. So we will directly do the sum. So first we will write ray CE bisects angle ACB. Okay. That is given. Now also what we know is DC is parallel to side BD. This we already know. Okay. And DCE is parallel to side BD and AD is the transversal. Okay. This they are talking about. This is parallel to this and AD is the transversal. Just write, and AD is the transversal. I think you already have done what is a transversal and everything in chapter 2 for 9th grade geometry. Okay. So if this is the thing, now see, try to understand. If AD is the transversal and this is parallel to this, then this angle will be equal to this angle. Okay. Why? They make ladder, means corresponding angles. Okay. So you have to write, therefore angle ACE is congruent or equal to angle CDB. See, I have written X and X. Okay. Right. Corresponding angles. Okay. So these are corresponding angles. Third. Okay. Now what else do we know? Again we know this is parallel to this, and say BC is the transversal. Okay. Take BC as the transversal. we'll come to know why we are doing all this. Ray C is parallel to side BD and BC is the transversal. Now in case where BC is the transversal, therefore see, you can see this angle over here. This will be equal to this. Now they are making a Z. Yes, they are making a Z. So this angle will be congruent to this angle. Okay, so then we write ECB is equal to angle CBD. Now Z means alternate angles. Alternate angles are congruent. Okay, so this we have done. Now from all of the above, from this 2 and 3, we come to know, see from 2 and 3, this is equals to this is equals to this. So we come to know that these two triangles, these two angles in this particular triangle are congruent. Why we need that, we'll come to know. So we come to know in triangle CDB, angle CDB is equals to angle CBD. So these two angles are equal. That is from 2 and 3. Yes? Okay. So from 2 and 3 they are equal. So what do we come to know? What do we conclude? Isosceles triangle. Okay. Isosceles triangle theorem. Therefore, if base angles are congruent, sides will be congruent. So we write CB is equals to CD, isosceles triangle theorem. Okay, so these are your 4 points. Now what do we do now? Now we are going to see how do we apply it to this. Now see this big triangle now, ABD. In ABD, this is parallel to this. So if I apply BPT, AE upon EB will be equal to AC upon CD. Yes or no? So let's apply that and see. I'll give you 2 minutes. Okay. So now in triangle, the bigger triangle we are talking about, I'm just adjusting the book. In triangle ABD, CE is parallel to BD. CE is parallel to BD by construction. Therefore, directly by BPT, what do we come to know? AE upon EB is equals to AE upon EB is equals to CA upon CD. CA upon CD. Yes? You can write AC also, AC upon CD, because it goes like this, but you can write CA upon CD also. Okay? But CD is nothing but CB. Therefore, A upon EB is equal to CA, and we replace CD by CB. So these are the 2 sides of the triangle. Okay? That is, this is by BPT and this is from 4. Okay, so this is your angle bisector property. Very important. It comes for the large group D sums. So don't miss it. It's very easy. If anybody has not understood it, you can message me. So now I'll directly give you all the gist of it. Okay, so let me give you all a gist of angle bisector property. Suppose this is my A, B, C and here E. Okay, this is the angle bisector, means ray B is the angle bisector for angle B. So directly, so this is the property and we have direct conclusion for it. Okay, that is AB upon BC is equals to AE upon EC. Please, it's not the other way around. नीचे से नहीं जाना है, तो ऐसे पहले 1, 2, 3 and 4. So if you start from AB, BC, then you have to do AE, EC. Okay, please remember 1, 2, 3 and 4. Okay, So this is for your angle bisector property. अगर आपको direct application करना है, अभी जैसे आप subs देखोगे तो, okay, these are the direct applications. This is your proof, means why we got this. Okay, now one more thing is there now, what we need to know before we start. That is property of three parallel lines. These are very, very nice and interesting properties. This help us to do the sums. They're not very difficult. They're very nice, easy. So with the help of BPT, we're going to prove this and then we are going to use it. Okay. So in this, the ratio of the intercepts made on a transversal by three parallel lines is equal to the ratio of the corresponding intercepts made on any other transversal by the same parallel line. So one transversal is here, the other transversal is here. So they are saying the intercepts made on by the three parallel lines on one transversal is equal to the ratio made by the three parallel lines on the other transversal. So in the end we have to prove that AB upon BC is equals to PQ upon QR. Now here also you will require construction. Okay, so see, this is the construction. We have to join BC and we just use BPT again. You consider this to be one triangle, consider this to be the other triangle. Okay, so let's going to start with the proof head on. Okay, you all can see all the given, any construction that is there, all you can see that is written over here on top. Okay, so let's do no, directly. I said here we are going to consider to be one triangle. Okay, this is going to be one triangle and the remaining is going to be the other. Remember, these three lines are parallel. So this is parallel to this, is parallel to this. Okay, that is our hint. So first I'll take this above triangle. Okay, in triangle ACP, BD is parallel to AP. Okay, that is given. Okay, because all the three lines are parallel and C dash, D dash, P. I told you these three are collinear. Therefore, AB upon BC is equals to PD upon DC by basic proportionality theorem. If sides are parallel, the sides are in. If the side is parallel to the line intersecting, then they divide in the same ratio. Okay, this is BPT. Now this triangle PCR. In triangle PCR, DQ is parallel to CR, that is given, and C dash, D dash, P. You have to just write because it's a construction, so they should know that these are collinear. Therefore, now in that PD upon DC is equals to PQ upon QR. Now we did these kind of sums yesterday. So now this is also by BPT. Sides are parallel, these two are parallel, this divides in the same ratio. BPT direct application. Now we can see PD upon DC, PD upon DC. Now this is property of transitivity. So therefore we come to know AB upon BC is equals to PQ upon QR is equals to PD upon DC. You can say from 1 and 2, or you can write by the property of transitivity. It will be good if you write that. But what do we want to know? We only want to know that is AB upon BC is equals to PQ upon QR. So to sum this up for you all, okay, I will tell you all that when three lines are parallel, okay, these are your three parallel lines. Okay, when three lines are parallel and two transversals cut them, they can cut in any. So this 1 upon 2 will be equal to 3 upon 4. It is compulsory. This is your property for three parallel lines. Okay. Now saying this, let's start with our solved examples. Now I explain the solved example, there is a reason, so that you all get a clear understanding. Many solved examples have been asked previously in your question papers and stuff. Okay, people neglect it, but they are very important. So we'll do example 2. Let's read. In triangle PQR, the RS is the angle, bisects angle R if PR is equals to 15, RQ is equals to 20, PS is equal to 12, SQ is equals to how much? Now this is your angle bisector property. Okay, this is bisecting. So if you start from here, PR upon RQ, if you do 1, 2, then you have to come down from P only, 3, 4. Okay, this is angle bisector property. ये angle bisector है, इसके ऊपर का side लो या तो इधर का. So you start from here, PRRQ. PR upon RQ is equal to PS upon SQ. If you start from P, you come down from there only. Okay, you're coming down PRRQ, then come down from here also. PS SQ. This is your angle bisector property. दिख रहा है इधर angle bisector दिया हुआ है. Given is bisects, so you have to use angle bisector. Okay. Solution. First step, you write as it is. Okay. In triangle PQR, segment RS bisects angle R. Given. Therefore, directly 1, 2, 3, 4. Please do that. 1, 2, 3, 4. Okay. So that is PR upon RQ. PR upon RQ. PR upon RQ is equals to PS upon SQ. This is by angle bisector property. Okay. Therefore, now these values are there. Okay. So PR is 15 upon RQ is 20, PS is 12, SQ we do not know. Say given. Okay. This we have marked it in the given. Therefore, cross multiply. 15 into SQ is equals to 12 into 20. Therefore, SQ is equals to 12 into 20 upon 15. Okay. See, cross this you take it up, this you take it up, and this you bring down. Okay. Now you cancel. Okay. Now you cancel. 5 3s are 5 4s are 3 1s are 3 4s are. Therefore, SQ is equals to 4 4s are 16. Now since centimeter or anything is not given, you say units. But do not forget to write units. So that's for your example 2. Let's do 2 activities and then we stop. Okay, for today. We stop for today after we do these 2 activities. Okay. Now, activity it is given over here. In the figure 1.13, AB is parallel to CD is parallel to E. This is direct applications. Okay, kids? There is no hard and fast, nothing. Direct application है तो direct application करो. Do not make mistakes in this. I am going to do the sum. You will do the fill in the blanks using my sums. Okay? If you want, I can explain the fill in the blank also कि कैसे directly लिख सकते हो आप fill in the blank कैसे कर सकते हो. Okay? We will do that next time. Okay? So AB is parallel to CD is parallel to F. Direct conclusion, this is parallel to this is parallel to this. Therefore, 1 upon 2 is equals to 3 upon 4. It's a direct application. There is no other way. Okay? So, I'll directly move on to the solution. Okay? So, that is AB is parallel to CD is parallel to EF. Okay? That is given. Therefore, direct AC upon CE is equals to BD upon DF. Okay? What you can say? Property of 3 parallel lines. Okay? ठीक है, therefore substitute the values now. 5.4 upon 9 is equals to 7.5 upon df. Okay, now again you have to just cross multiply. Okay, so 5.4 into df is equals to 7.5 into 9. Now what happens is we have to take it down. So before that, as I told you, remove the decimals. It's easy. Into df, ये upon 10 आ जाएगा, is equals to 75 into 9 upon 10. Now df is equals to, excuse me, this will go up, this 10 goes up in the numerator, 54 comes down, excuse me, as the denominator. Okay, ones are 50, 10, 10 ones are, 10 ones are, it gets cancelled, 9 ones are, 9 6 are. Now if you divide, df will come in decimals. Okay, your df will come in decimals. Okay, so that dash units. Okay, I want you to put the answer in the comment section. Everything I did for you, put the answer in the comment section. Now we will discuss the last sum for this particular part. Very easy, interesting and very important activity. It can be asked as an activity or it will be asked as a direct sum. In triangle ABC, ray BD bisects angle ABC. A dash D dash C side DE is parallel to BC. So I'll mark it over here. Side DE is parallel to BC. इधर ही इंटरेस्टिंग हो जाता है. ये हुआ तो डायरेक्टली पुट BPT. Then AEB. Then prove that you have to prove that AB upon BC is equals to AE upon EB. So forget what you have to prove. ये तो जो दो प्रॉपर्टी दी अप्लाई कर दो. See, ray bisects is given and parallel is given. Apply both the properties, then we'll see what to do. Okay, you get your answer as it is. Okay, first we will apply the ray. Okay, in triangle ABC, ray BD bisects angle ABC. Apply. Okay, that is given. Apply the property now. Okay, 1 2 3 4. Okay, so that is, forget that ED exists. ये इधर आपका bisector दिख रहा है, this. So these are the two sides and this is it divides. So 1 2 3 and 4. So it will be AB upon BC is equals to AD upon DC by angle bisector theorem or property. Okay, then second step is now DE is parallel to BC in triangle ABC. This is again given. Direct application. This is parallel to this. Therefore, it's a very easy and nice sum. AB upon, AE upon EB. Okay, this is parallel. So AE upon EB is equals to AD upon DC. Is equals to AD upon DC. Again, you will see the property of transitivity will be used over here. This is equals to this. This is also equals to this. So you can say by BPT. Sorry for all the clutter. Try to have a margin over here. So third one. Okay. So therefore we come to know that AB upon BC is equals to AE upon EB from 1 and 2. Okay. So I think you have understood all the examples in this part. In the next we will deal with all the examples of the practice set 1.2. Thank you.
So hope you've all enjoyed this part of the chapter series just as you would enjoy your favorite book with a hot cup of tea. So, ECOT that is Everyone's Cup of Tea, will bring to you many more such chapter series along with detailed explanation and solution of the exercises that are there in your textbook. We wish to bring to you this and more at zero cost so that the hardest chapters become your cup of tea. So help us by clicking on this button. Get notified about our upcoming chapter series. Also, share it to help us define education through equality. Do message us any doubts that you have on our Instagram handle, Everyone's Cup of Tea, and we promise to answer them. Thank you and keep sipping. Bye.